Okay, now that we've talked in general terms about data center storage, data stores, NAS, vSANs, and the like, we're going to get specific on VMware, and then we're going to do the same thing with Hyper-V. Now, don't worry if you look at that 1 of 13 and think this video is going to take forever. It's not, because I'm going to break it up. I'm going to start by talking about vSphere storage, then we're going to talk about vMotion and DRS, and then we're going to talk about vSANs. So it's going to be 3 videos, not one ginormous one. So as I've mentioned before, whereas Hyper-V uses NTFS and potentially REFS for its data stores, VMware uses the VMware file system VMFS to store and manage those data stores on both locally and shared SAN storage. This can include, so these SANs could be either fiber channel or iSCSI. VMFS is a high-performance clustered file system. It's designed to support VMs. Now, NTFS could just as easily be built as a file server. VMFS is designed specifically to support VMs. You can increase your data store capacity while VMs are running. You can provide virtual disk files that are up to 2 terabytes in size. Now, because we could also do this with, say, thin provisioning, you don't necessarily have to have all 2 of those terabytes on hand now. You could throw more storage into the system as you get it and grow. But just make sure that you don't bite off more than you can chew. Don't overbook yourself or overcommit yourself. This is also called oversubscription too dramatically. If you're going to play this particular game, play it carefully. We can also, because this is designed for very large files, up to 2 terabytes in size, but also very small files for, say, VMXs and log files and things like that. So we can also support those with subblock addressing. A VMDK is, as we know, the format used for VMware virtual disks. You can move that VMDK file from one physical disk system to another, and it won't discombobulate anything. One of our goals with vSphere storage is clustering and high availability. You can cluster multiple vSphere hosts. You can cluster the storage available through those hosts. And with those clusters managed from a central vCenter location with, say, vCenter monitors on the individual hosts, you provide continuous access. The application running on those VMs doesn't need to know about the clustering. It just knows, hey, I've got storage. And the cluster in the backend can move things around. Now, to have high availability, you have to have at least 2 ESXi hosts with a common data store and common network connectivity. What that really means is that they should have a management network common between them, and probably also a storage area network in common between them, so they can both get to the same data store. If those 2 ESXi hosts aren't using a common data store, you can't cluster them for this purpose. They may be doing other things, but for this purpose, you can't cluster them. Now, high availability is technically slightly different from fault tolerance. Now, remember that fault tolerance is, in this case, high availability means that there might be some downtime. True fault tolerance means that there's literally a second copy of the VM running on a second host, kept up to date with lockstep, so that if the first VM drops, the second one it just falls over to the next one seamlessly. With high availability, there's going to be a little bit of downtime. With fault tolerance, there's none, which is actually kind of the reverse of how we would normally use the words fault tolerance. Because think about it, except in cases where you're building a redundant architecture, say multiple routers, multiple switches, multiple cables, ether channel, channel bonding, the whole 9 yards. If one of those pieces of equipment fails, you've still got connectivity. But if we think in terms of hard drive or storage fault tolerance, if a drive in a fault-tolerant array dies, you still have to shatter, you still have to replace the drive and rebuild it. So there will be some downtime there. So this is not quite that. So pay attention to that difference. So this is kind of what it looks like. In a high availability cluster, so you've got your ESXi host. Each one of these has an active and an inactive VM, and there's a beacon packet going back. The beacon packets going from each of the hosts in this cluster to a vCenter server that's managing the whole situation. And if the beacon packet fails, stops, the systems can assume, okay, it's gone. And they might do some other cross-checking, actually reach into the storage and say, hey, is there still a lock on that file? If the beacon packet is no longer transmitting, but there's still a lock on the file, that suggests, hey, it's still up. I can't talk to it, but it's still up, so I'll leave it alone. If everything fails, then both of these active VMs can move over. And also, they're still using these data stores. So there's a data store here, and it doesn't really matter which of these two hosts is running which of these two VMs. They could just as easily support them both. And your VM clients don't know the difference. And that's kind of the whole point, as I said. So we'll talk about vMotion and DRS in just a minute. Thank you for watching.